Hello friends, now we'll start the last topics of this chapter, that is the hyperbola. In these topics, we'll see the standard equation of the hyperbola, equation of the tangents, and all the problems from the exercise. Now let us start. Standard equation of hyperbola. Equation of tangent to the hyperbola. Condition for tangency. Now the definition. Hyperbola is the intersection of double napped cone with the plane parallel to the axis. That is, if we take the plane and when that plane is a parallel to the axis of the nap, then intersect it, then we get the hyperbola. Again, the hyperbola is the locus of a point in a plane which moves so that a distance from a fixed point bears a constant ratio E, which is greater than 1 to its distance from fixed line. The fixed point is called focus and the fixed line is called the directrix of the hyperbola. Now this is the definition. You can write this definition. Now next is, now say this is the hyperbola. P is a point on this hyperbola at a distance from the fixed point S, which is the focus, and the perpendicular distance on the directrix. Now in this case, the equation of the directrix is x minus a upon e is equals to 0. Now a is the vertex, this is the directrix, x-axis and the y-axis. Now see this here. If S is the focus and D is the directrix, not focus, and P is moving, then PS upon PM, PS upon PM, that is equals to E. That is the point of, this is the locus of points such that PS upon PM is equals to E. The value of the E is greater than 1. If we join all such points, then we get the hyperbola. Where the PM is the perpendicular on the directrix, PM is a perpendicular on the directrix, and the value of E is called eccentricity is a greater than 1 of the hyperbola. Standard equation of the hyperbola. Now the derivation. Hyperbola's standard derivation आपण derive करणार. Actually, the equation of the ellipse and the hyperbola, both are the same, only the difference is that plus and minus sign is in between them. That is, let S be the focus and D be the directrix, E be the eccentricity of a hyperbola. Draw SZ perpendicular to directrix. SZ perpendicular to directrix. This is the directrix. Next, let A and A dash divide the segment SZ internally and externally in the ratio A:1. By definition, A and A dash lie on the hyperbola. Let A dash is equals to 2A. This is the A dash is equals to 2A. Midpoint O of segment A dash B, origin. Then O is 0, 0 and A is A0 and A dash is a minus A0. Now SA upon AZ is equals to E:1. This is the point A and A dash, that is equals to 2A. The coordinate of A is A0 and A dash is a minus A0. S A dash and A dash Z is equals to minus E upon 1. Now in this case, SA is equals to E into AZ. Let, that is Z is K0 and S is H, 0. These are the points. By the section formula, for the internal division and the external division, that is A is equals to EK plus H into 1. 1 into H upon E plus 1. See this again here. These are the points. That is E, and this is the one part, A:1, and therefore we treat as E into H and 1 into K upon E plus 1. This we treat as the coordinate of S is H, 0 and Z is K, 0. After the solving, we are getting this, the coordinate of S is in place of H is A. But before that, we will find out the coordinate of H, which is the A, and also the coordinate of the K by using the section formula. That is, this point A divides SZ in the ratio A:1. Now, next is also for the external division, that is a EK minus 1H upon E minus 1. AE plus A is equals to EK plus H. This is number 2. Minus AE plus A is equals to EK minus H. This is equation number 2. Now we'll solve these two equations and we will get the value of H and K. Now see this, you can write this also. Therefore, the value of K is A upon E and AE plus A is equals to EK plus H. Therefore, the value of H is AE and K is A upon E. Therefore, F, that is the focus, S, AE 0 and Z, A upon E 0. Now the equation of directrix is X is equals to A upon E. That is X minus A upon E is equals to 0. Now we'll apply the focus directrix property. Let P xy be any point on the hyperbola. This is the point on the hyperbola. And then we take the ratio SP upon PM. That is equals to E. SP, that is a focal distance. Means what? The distance from the focus of the point P. Therefore, SP is equals to focal distance. We will apply the distance formula. X minus AE bracket square plus Y minus 0 bracket square. This is the 4. This is the SP. PM, distance of P from the directrix. That is, we will find out the perpendicular distance of the point P on the directrix. That is, X minus A upon E is equals to 0. Therefore, X minus A upon E in root of 1, that is. Therefore, this is by using the perpendicular distance formula that we have learned in the straight line chapter and solve the number of examples. This is the 1, and therefore from 1, 4, 5, SP is equals to E times PM. And now simplify this, squaring on both sides. You will get after multiplication, E is multiplied to the X minus, that is A upon E, then you will get EX minus A, squaring on both sides. Therefore, after the squaring, that is a EX minus A bracket square is equals to EX bracket square minus 2 EAX plus A square, and the squaring of these two brackets also, X square minus 2 XAE plus Y square. Therefore, X square, that is some terms will get cancelled on both sides. That is X square plus A square E square plus Y square minus E square X square is equals to A square. Now take X square as a common. Now simplify like this. X square is common. Dividing on both sides. E is greater than 1. E square minus 1. X square. Now as E is greater than 1, E square minus 1 into X square minus Y square is equals to A in bracket E square minus 1. Therefore, it can be written as like this. Dividing on both sides by A square in bracket E square minus 1. Therefore, you will get dividing on both sides. Therefore, X square upon A square minus Y square upon A square in bracket E square minus 1 is equals to 1 minus Y square upon B square is equals to 1. Where b square is equals to a square in bracket is square minus 1. This is the standard equation of hyperbola. Let s dash be minus a is 0 and d dash be the line x is equals to minus a upon e, because it is on the left side of the y-axis. For any point P on the hyperbola, Pm dash is perpendicular on D dash. It can be verified that Ps dash is equals to E times Pm dash. Ps dash is equals to E times Pm dash. Thus, for the hyperbola, A is 0 and minus A is 0 are two foci, and x is equals to a upon e and x is equals to minus a upon e are corresponding to directrix. Now some useful terms of hyperbola. Equation of hyperbola x square upon a square minus y square upon b square is equals to 1. The first is hyperbola intersect x-axis at this point a 0 and a dash is minus a comma 0. Next, it does not intersect y-axis, does not intersect the y-axis. It does not intersect the y-axis. It intersects x-axis and x-axis here, but it does not intersect the y-axis. Now next, the segment a dash of the length 2a is called the transverse axis, and the segment bb dash of length 2b is called conjugate axis, transverse axis and the conjugate axis. Now this is the hyperbola. The line segment through the foci of the hyperbola is called the transverse axis, and the line segment through center and perpendicular to the transverse axis, this is the is called conjugate axis. This is the conjugate axis. The transverse axis and conjugate axis together are called principal axis of the hyperbola. In standard form, x-axis is The transverse axis and y-axis is called the conjugate axis. Latus rectum is the chord passing through the focus which is perpendicular to transverse axis. It is bisected at the focus. There are two latera, area as this is the latus rectum, is perpendicular to the transverse axis, L dash and T dash. Now the distance between some regions, directrix, that is a 2a upon e, that is a 2ae. Endpoints of a latus rectum, that is a ae b square upon e, L dash ae minus b square upon e. Length of a latus rectum, that is a 2b square upon e. These formulae you have to remember. A circle drawn with the transverse axis AA dash as a diameter is called an auxiliary circle of the hyperbola, and its equation is x square plus y square is equals to a square. This is the auxiliary circle. Its equation is a x square plus y square is equals to a square. X square plus y square is equals to x square. Next is parametric equation of hyperbola. Parametric equation of the hyperbola. X is equal to theta and y is equals to b tan theta. This you have to remember. Are called the parametric equations of the hyperbola. Next is other standard form of hyperbola. This is the transverse axis is along the y-axis. Is called the conjugate hyperbola. Now these are the important formula. This is hyperbola, that is x square upon a square minus y square upon b square is equals to 1, and y square upon b square minus x square upon a square is equals to 1. Their centers are same. Axis of symmetry, both x-axis and y-axis, and the vertices a dash, b dash, and here is also a dash and b dash. Next is a measure of the transverse axis, that is a axis, and the minor axis, that is a conjugate, x and y axis, that is the transverse axis is x and the conjugate axis is y here. And for this here, the transverse axis is y and the conjugate is x. Length of transverse axis is 2a, here is a 2b, conjugate is a 2b and 2a. You can remember this. Next is next part is the foci. That is a is 0 minus a is 0. Here is a 0 be and 0 minus be. Distance between the foci, that is a 2a, 2b. Equation of the directrix, x is equals to a upon e and x is equals to minus a upon e. Y is equals to b upon e and y is equals to minus b upon e. Distance between their directrix, 2a upon e, 2b upon e. Endpoints of the lattice rectum, that is L, A, B square upon E and L dash A minus B square upon E. And in this case, the change is like this. That is L, A square upon B, B. You can remember how to remember this. That is L dash is minus A square upon B and B. लक्षात ठेवण्यासाठी बघा इथे तसा त्यामध्ये चेंज घेतलेला असतो. Next is the length of the lattice rectum 2b square upon a आणि इथे मात्र 2a square upon b. Length of the lattice rectum, parametric equation, x is equals to a sec theta and y is equals to b tan theta. Here is x is equals to a tan theta and y is equals to b sec theta. Equation of the vertex, equation of the tangent at the vertex is equals to a, x is equals to minus a, y is equals to b, y is equals to minus b, and sum of the focal distance of a point, that is a length that is equals to 2a and this is the 2b. Now the equation of the tangent to a hyperbola. Now this is the hyperbola. It is a tangent at the point P. In the same way, we will derive the equation of the tangent to the hyperbola. Actually, in the 12th standard application of the derivative, we can find out the slope of the tangent at a point to the different types of the curves. That is a circle, parabola, hyperbola, and the ellipse. By differentiating it, we get the gradient there. And that is nothing but the slope of the tangent at that point. Now, we want to here find out again the slope of the tangent. We will require the slope. We know the point. To find out the point, we will differentiate it. And that type of the differentiation is implicit type of the derivative that you will learn in the 12th standard. Now the line is a tangent at the point P xy. Therefore, now we will derive the equation of the tangent to the hyperbola. A straight line which intersects the hyperbola into coincident point is called a tangent to the hyperbola. Tangent on a hyperbola. To find the equation of the tangent to the hyperbola, x square upon x square, y square upon b square is equals to 1 at P, x1, y1 on it of the tangent, that is, now see this here, to find the equation of the tangent to the hyperbola, again I am repeating, x square upon a square, y square upon b square is equals to 1 at the point P x1, y1 on it. Hence, to obtain the equation of tangent at P theta 1, we need to know the slope of the tangent at P x1 y1. The equation of the hyperbola is x square upon a square minus y square upon b square is equals to 1. Differentiate both sides with respect to x. That is a derivative of x square is, this is the implicit type of the function, and this differentiation you will learn in the 12th standard. That is a derivative of x square is 2x, a square is a divided constant minus derivative of y square is a 2y upon b square into dy by dx equals to derivative of the constant. This is the one, it is the independent of x and its a derivative is a 0. Therefore, 2x upon a square minus 2y upon b square into dy by dx is equals to 0. Therefore, dy by dx is equals to x b square upon y a square. This is the dy by dx at the point x1 y1. That is a x1 b square upon y1 a square. This is the slope of the tangent at the point x1 y1 to the given curve. Now the equation of the tangent by the slope point form, that is a y minus y1 is equals to m in bracket x minus x1. Now we derive this equation. The value of m, that is x1 b square upon y1 a square in bracket x minus x1. Now the simplification. This is the simplified form. That is y minus y1 into y1 a square is equals to x1 b square in bracket x minus x1. Now their multiplication. y1 a square minus y1 square into a square x1 x b square minus x1 square b square, that is a x1 square b square minus y1 square a square is equals to xx1 b square minus y1 a square, dividing on both sides by a square b square, then you will get x1 square upon a square minus y1 square upon b square is equals to xx1 upon a square minus y1 upon b square. Now it's a value, but the point px1 y1 is lie on the hyperbola. Therefore, x1 square upon a square minus y1 square upon b square is equals to 1. Therefore, xx1 upon a square minus y1 upon b square is equals to 1. This is the equation of the tangent to the hyperbola at the point x1 y1. It's a parametric form, that is the point x1 y1 is equals to a sec of theta and b tan of theta. Substitute in equation 1, then you will get the x1 is replaced by a sec theta and y1 is replaced by b tan theta. Then you will get x a sec theta upon a square minus y b tan theta 1 upon b square. That is, we are treating it is at the point theta 1. And after the cancellation, you will get x sec theta 1 upon a minus y tan theta 1 upon b is equals to 1. This is the equation of the tangent to the given curve. At the point b theta 1. Now the condition for the tangency. Before these topics, we have seen the condition for the tangency for the circle, parabola, ellipse, and now the condition for the tangency for the hyperbola. It means that when a given line will be the tangent to the given curve. To find the condition that the line y is equals to mx plus c is tangent to the hyperbola x square upon a square minus y square upon b square is equals to 1. Now, equation of the line is y is equals to mx plus c, that is mx minus y plus c is equals to 0. This is the one. Equation of tangent at px1y1 to the hyperbola x square upon a square minus y square upon b square is equals to 1 is x1 upon a square minus y1 upon b square is equals to 1. x1 upon a square minus y1 upon b square minus 1 is equals to 0. Now comparing the coefficient, that is equation 1 and equation 2 are identical. Therefore, now see this, x1 upon a square upon mx is equals to minus y1 upon b square upon minus 1 is equals to c upon minus 1. Now from this we will find out the values of x1 and y1. Now here x is get cancelled, y also get cancelled. Therefore x1 upon ma square is equals to minus 1 upon c, and y1 upon b square is equals to minus 1 upon c. Therefore the value of x1 is a square m upon c, and value of the y1 is minus b square upon c. This is the point of the contact of the given tangent to the hyperbola. Now this point lies on the hyperbola. It satisfies the equation of the hyperbola. Therefore substitute the values of x1 and the y1. Then we will get the required condition, that is a raised to 4m square upon a square c square minus b raised to 4 upon b square c square is equals to 1, a square m square upon c square minus b square upon c square is equals to 1, a square m square minus b square is equals to c square. That is c square is equals to a square m square minus b square. Therefore, c is equals to plus or minus in root of a square m square minus b square. This is the condition for the tangency. If the any line is a tangent to the hyperbola, then it must satisfy this. That is, a c is equals to. Thus, the line y is equals to mx plus c is tangent to the hyperbola x square upon a square minus y square upon b square is equals to 1 if c is equals to plus or minus in root of a square m square minus b square, and the point of contact is minus a square m upon c minus b square upon c. Now next is the equation of tangent in terms of slope is y is equals to mx in root of a square m square minus b square. This is the equation of the tangent in terms of the slope. Tangents from a point to the hyperbola, that is, a two tangent can be drawn to the hyperbola from any point outside the hyperbola in its plane. That is, we can draw the two tangent to the hyperbola from the outside point. Let P x1 y1 be any point in the plane of the hyperbola. The equation of the hyperbola is y is equals to mx. Equation of the tangent to the hyperbola is y is equals to mx plus or minus in root of a square m square minus b square. If the tangent passes through x1 y1, y1 is equals to mx1 plus or minus in root of a square m square minus b square. y1 minus mx1 is equals to plus or minus in root of a square m square minus b square. Therefore, squaring on both sides, that is a y1 minus mx1 bracket square is equals to a square m square minus b square. Now expanding this, y1 square minus 2mx1 y1 plus m square x1 square is equals to a square m square minus b square. That is the x1 square minus a square into m square minus 2mx1 y1 plus y1 square minus b square bracket complete is equals to 0. Now from this equation we will find out the sum of the roots and the products of the roots. That is, it has two roots, say m1 and m2, which are the slopes of the two tangents. Thus, in general, two tangents can be drawn. That is, there are the two values of m. Means what? The two tangent which passes through the same point but have the different slopes from a given point in its plane. Sum of the roots. Now the sum of the roots is minus b upon a, that is a minus in bracket minus 2x1 y1 upon x1 square minus a square, that is a 2x1 y1 upon x1 square minus a square. Products of the roots, m1 x1 is equals to y1 square plus b square, x1 square minus b square, locus of point of intersection of perpendicular tangents if the tangent drawn from P are mutually perpendicular, then we have m1 into m2 is equals to minus 1, that is the product of the slope is minus 1, that is the minus 1 is equals to y1 square plus b square upon x1 square minus a square, and if you simplify this, then you will get that is equals to minus in bracket x1 square minus a square is equals to y1 square plus b square. This is equals to x1 square plus y1 square is equals to a square minus b square, which is the equation of standard circle with center at origin and radius a square minus in root of a square minus b square, where a is greater than b. This is called the director circle of the hyperbola. Now next, exercise 7.3. Find the length of transverse axis, the length of conjugate axis, eccentricity, the coordinates of the foci, equations of directrix, and the length of latus rectum of the hyperbola. First, x square upon 25 minus y square upon 16 is equals to 1. Now comparing with x square minus a square, x square upon a square minus y square upon b square is equals to 1. The value of a square is 25 and the value of b square is 16. A is equals to 5, b is equals to 4. Now the length of transverse axis, that is equals to 2a, 2 into 5, that is equals to 10. Length of conjugate axis, that is a 2b, 2 into 4, that is equals to 8. Eccentricity, E is equals to in root of a square plus b square upon a, that is equals to 25 plus 16 upon 5, that is a root of 41 upon 5. Next, Therefore, E is equals to in root of 41 upon 5. 4. Coordinate of the foci are A is 0 plus or minus A is 0. A into E is equals to 5 into root of 41 upon 5. That is a root of 41. That is a plus or minus root of 41 upon 41, 0. This is the coordinate of the foci. Equations of directrix are x is equals to plus or minus A upon E. That is a plus or minus 5 upon in root of 41 upon 5. That is a plus or minus 25 upon root of 41. Therefore, x is equals to plus or minus 25 upon root of 41. 6. Length of a lattice rectum, that is a 2b square upon a, 2 into 16 upon 5, that is a 32 upon 5. This is the length of lattice rectum. X square upon 25 minus y square upon 16 is equals to minus 1. That is y square upon 16 minus x square upon 25, that is equals to 1. Therefore, comparing with the hyperbola y square upon a square minus y square upon b square minus x square upon a square equals to 1, we get a square equals to 25, b square is 16. A is equals to 5, b is equals to 4. Now the length of transverse axis, that is a 2b, is equals to 2 into 4, that is equals to 8. Next is length of conjugate axis, that is equals to 2a, 2 into 5, that is equals to 10. Length of conjugate axis 10. Next, eccentricity, E is equals to in root of a square plus b square upon b. Substitute the value 16 plus 25 upon 4, that is the root of 41 upon 4. Next is focus, that is a BE. 4 into root of the value of E is root of 41 upon 4, that is a B is equals to root of 41. Coordinates of the foci, that is a 0 plus or minus BE, that is a 0 plus or minus in root of 41. B upon E is equals to 4 upon in root of 41 upon 4, that is a 16 upon root of 41. The equations of directrix are y is equals to plus or minus b upon e, that is y is equals to plus or minus in root of 16 upon root of 41. Length of lattice rectum 2a square upon b, that is a 2 into 25 upon 4, that is equals to, we will see, length of lattice rectum 2a square upon b, that is a 2 into, this is the 25 upon 2. Third, 16x square minus 9y square is equals to 144. Dividing on both sides by 144, x square upon 9 minus y square upon 16 is equals to 1. Comparing with x square upon a square minus y square upon b square is equals to 1. A square is 9, b square is 16. A is 3, b is equals to 4. The length of transverse axis, that is a 2a, 2 into 3, that is equals to 6. Length of conjugate axis, that is equals to 2b, 2 into 4, that is equals to 8. Eccentricity, E is equals to in root of a square plus b square upon a. Now substitute the value. 9 plus 16 upon 3. 5 upon 3. A is equals to 5 upon 3. Fourth one, focus, that is a plus or minus a comma 0. That is a is equals to 3 into 5 upon 3, that is equals to 5. That is focus is equals to plus or minus 5, 0. Equations of directrix, x is equals to plus or minus a upon e. The value of a is and e, that is equals to, that is a 3 upon 5 upon 3, that is 3 upon 1 into 3 upon 5, that is x is equals to plus or minus 9 upon 5. Length of latus rectum, that is a 2b square upon a, 2 into 4 upon 3, 8 upon 3, that is a 4 square, that is a 16, 16 into 2, 32 upon 3, length of latus rectum. Next is 21x square minus 4y square is equals to 84. Dividing on both sides by 84, then you will get 21x square upon 84 minus 4y square upon 84 is equals to 1. X square upon 4 minus y square upon 21 is equals to 1. Therefore, here a square is 4, b square is 21. Now first is a is equals to 2, b is equals to root of 21. The length of transverse axis, that is a 2a, 2 into 2, that is 4. The length of conjugate axis, that is a 2b, 2 into root of 21, that is a 2 root 21. Eccentricity, a is equals to in root of a square plus b square upon a, that is a 4 plus 21 upon 2, that is a 25 upon 2, 5 by 2. A is equals to 5 by 2. Fourth one, coordinates of focus, that is a plus or minus a is 0, a into e. Substitute the values. 2 into 5 by 2, that is 5. Therefore, AC is plus or minus 5, comma 0. Fifth one, the equations of directrix are x is equals to plus or minus a upon e, that is a 2 into 5 upon 2, that is a 2 get cancelled, you will get 5. Therefore, x is equals to plus or minus 5. Sixth one, a length of a lattice rectum, that is a 2b square upon a, that is a 2 into 21 upon 2, and that is equals to 21. This is the length of lattice rectum. Fifth one, 3x square minus y square is equals to 4. Dividing on both sides by 4. Therefore, we will get, that is a 3x square upon 4 minus y square upon 4 is equals to 1. X square upon 4 upon 3 minus y square upon 4, and that is equals to 1. A square is equals to 4 upon 3, b square is equals to 4, a is equals to 2 upon root 3, and b is equals to b is equals to, so by mistake, b is equals to 2. Now the length of transverse axis, that is a 2 into 2 upon root 3, that is a 4 upon root 3. This is the length of the transverse axis. The length of conjugate axis 2b, that is equals to 2 into 2, that is equals to 4. Eccentricity, E is equals to in root of a square plus b square upon a, that is a 4 upon 3 plus 4 upon 2 upon root 3, 16 upon 3 in root of 16 upon 3 upon 2 upon root 3, that is a 4 upon root 3 multiplied and reciprocal root 3 upon 2, then you will get 2. Therefore, E is equals to 2. Fourth one, coordinate of foci, that is a plus or minus A is 0. Therefore, A into E, that is a 2 upon root 3 into 2, that is equals to 4 upon root 3. Coordinates of foci, that is a plus or minus 4 upon root 3, 0. Fifth one, equations of directrix are x is equals to plus or minus A upon E, that is a 2 upon root 3 upon 2, that is a 2 upon root 3 into 1 upon 2, that is a x is equals to plus or minus 1 upon root 3. Sixth one, length of lattice rectum, that is a 2b square upon a, 2 into 4 upon 2 upon root 3, that is 8 upon 1 into root 3 upon 2, that is equals to 4 root 3. This is the length of the lattice rectum, 4 root 3. Now sixth one, x square minus y square is equals to 16. Dividing on both sides by 16, then x square upon 16 minus y square upon 16 is equals to 1. Comparing with x square upon a square minus y square upon b square is equals to 1, we get a square is equals to b square is equals to 16. A is equals to b is equals to 4. Let length of transverse axis, that is equals to 2a, 2 into 4, that is equals to 8. Length of conjugate axis, that is equals to 2b, 2 into 4, that is equals to 8. Eccentricity, E is equals to in root of a square plus b square upon a, that is 16 plus 16 upon 4, that is the root of 32, that is a 4 root 2, that is e is equals to root 2. Fourth one, coordinates of foci, that is a plus or minus AE0. Now their values, A is equals to 4 root 2 is equals to 4 into root 2, that is a plus or minus 4 root 2 0. Fifth one, equation of directrix are x is equals to plus or minus a upon e, 4 upon root 2, that is equals to 4 into root 2 upon multiplied n and d by root 2. Then after simplification you will get 4 root 2 upon 2, that is a 2 root 2. Therefore x is equals to plus or minus 2 root 2. Sixth one, a length of latus rectum, that is a 2b square upon a, 2 into 16 upon 4, that is a 2 into 4, that is equals to 8. This is the length of latus rectum. Now seventh one, y square upon 25 minus x square upon 9 is equals to 1. Comparing with y square upon b square minus x square upon a square is equals to 1. Therefore, we get b square is equals to 25, a square is equals to 9, b is equals to 5, a is equals to 3. The first is length of transverse axis, that is a 2b, 2 into 5, that is equals to 10. Length of conjugate axis, that is a 2a, 2 into 3, that is equals to 6. Eccentricity, E is equals to in root of a square plus b square upon a upon b. Therefore 25 plus 9 upon 5, that is the root of 34 upon 5. E is equals to root of 34 upon 5. Fourth one, coordinate of foci, that is a 0 plus or minus b. B is equals to 5 root of 34 upon 5, 5 get cancelled, then you will get a root of 34. This is b is equals to root of 34. That is foci is equals to 0 plus or minus root of 34. Fifth one, the equations of directrix are x is equals to plus or minus b upon y upon b, that is equals to plus or minus 5 upon root of 34 upon 5. Then after simplification, that is a plus or minus 5 upon 1 into 5 upon root of 34, that is equals to plus or minus 25 upon root of 34. Length of latus rectum, that is a 2a square upon b, 2 into 9 upon 5, that is 18 upon 5, that is LR is equals to 18 upon 5. Eighth one, y square upon 25 minus x square upon 144, that is equals to 1. Comparing with y square upon b square minus x square upon a square, that is equals to 1. The value of b square is 25, a square is 144, b is equals to 5, a is equals to 12. Therefore, length of transverse axis, that is equals to 2b, 2 into 5, and that is equals to 10. Length of conjugate axis, that is equals to 2a, 2 into 12, that is equals to 24. This is next is a is equals to in root of a square plus b square upon b, that is in root of 25 plus 144 upon 5, that is a 169 upon 5, 13 upon 5. This is the value of the. Next is fourth one, coordinates of foci, that is a plus or minus a is 0, a is equals to the coordinates of the foci are 0 plus or minus be, that is we'll find out the value of the be, that is 5 into 13 upon 5, 5 get cancelled, b is equals to 13, and therefore the coordinate of the foci is a 0 plus or minus be, means 0 plus or minus 13. Fifth one, equations of directrix, that is y is equals to plus or minus b upon e. Therefore, plus or minus 5 upon 13 upon 5. Then after simplification, you will get 25 upon 13. Y is equals to plus or minus 25 upon 13. Sixth one, length of latus rectum, that is equals to 2a square upon b, 2 into 144 upon 5, that is equals to 288 upon 5. LR is equals to 288 upon 5. Now next is ninth one, x square upon 100 minus y square upon 25 is equals to 1. Comparing with x square upon a square minus y square upon b square is equals to 1. A square is 100, b square is 25. A is 10, b is equals to 5. Therefore, the length of transverse axis 2a, that is a 2 into 10, that is equals to 20. The length of conjugate axis 2b, that is equals to 2 into 5, that is equals to 10. Eccentricity E is equals to a square plus b square upon a, that is equals to 100 plus 25 upon 10, that is equals to 125 upon 10, that is a 5 root of 5 upon 10, that is equals to root 5 upon 2. Therefore, E is equals to root of 5 upon 2. Next is coordinates of foci, that is equals to plus or minus a 0, that is a 10 root 5 upon 2, that is 5 root 5, that is a plus or minus 5 root 5 0. Fifth one, equations of directrix are x is equals to a upon e, that is equals to 10 upon root of 5 upon 2, that is a 10 upon 1 into 2 upon root of 5, that is a 20 upon, that is equals to plus or minus 20 upon root of 5. You can simplify the limit. And the next is the length of the lattice rectum, 2b square upon a, that is a 2 into 25 upon 10, that is equals to 5. Therefore, the length of lattice rectum, that is equals to 5. Therefore, x is equals to 2 sec theta and y is equals to, next is 10. X is equals to 2 sec theta and y is equals to 2 root 2 tan theta. For this, the value of for this hyperbola, which is in the parametric form, x is equals to 2 sec theta and y is equals to 2 root 2 tan theta. Comparing with x is equals to a sec theta. Now comparing this with x is equals to a sec theta and y is equals to b tan theta. A is equals to 2, b is equals to 2 root 3. Length of transverse axis, that is a 2a, 2 into 2, that is equals to 4. Length of conjugate axis, 2b, that is a 2 into 2 root 3, that is a 4 root 3. Next is eccentricity. E is equals to in root of a square plus b square upon a, that is in root of 4 plus 12 upon 2, that is equals to 16 upon 2. 4 upon 2, that is E is equals to 2. Fourth one, coordinates of foci, that is the plus or minus A is 0. That is a 2 plus or minus 2 into 2, 0. That is plus or minus 4 comma 0. Next is equations of directrix are x is equals to plus or minus a upon e, that is equals to plus or minus 2 upon 2, x is equals to plus or minus 1. Length of lattice rectum, 2b square upon a, that is a 2 into 12 upon 2, that is equals to 12. This is the length of lattice rectum. Now the question number 2. Find the equation of the hyperbola with center at the origin, length of conjugate axis 10 and one of the foci, that is a minus 7. Now we'll start here. Due to mistake, some page was up and down. Find the equation of the hyperbola that is, let's the equation of the hyperbola is x square upon a square minus y square upon b square is equals to 1. The length of conjugate axis, that is 2b is equals to 10, therefore b is equals to 5. One of the focus is minus a 0, which is minus 7 0. B square is equals to a square in bracket e square minus 1, a square e square minus a square, that is a 5 square is equals to 7 square minus a square, and the value of a square is 49 minus 25, that is a square is equals to 24. Therefore by 1 The equation of the hyperbola is x square upon 24 minus y square upon 25, that is equals to 1. Find the eccentricity of the hyperbola, which is conjugate to the hyperbola x square minus 3y square is equals to 3. Given by the hyperbola x square minus 3y square is equals to 3. X square upon 3 minus y square upon 1 is equals to 1. Conjugate hyperbola, that is x square upon a square minus y square upon b square is equals to 1. That is y square upon is y square upon b square minus x square upon a square is equals to 1. Therefore, y square upon 1 minus x square upon 3 is equals to 1 is the conjugate hyperbola of the given hyperbola. Therefore, b square is equals to 1 and a square is equals to 3. E is equals to in root of a square plus b square upon b. Substitute the values 1 plus 3 in root of 1 plus 3, that is 2. E is equals to 2. Fourth one, if E and E dash are the eccentricities of a hyperbola and its conjugate hyperbola respectively, prove that 1 upon E square plus 1 upon E dash square is equals to 1. Let E and E be the eccentricity of the hyperbola x square upon a square minus y square upon b square is equals to 1. E is equals to in root of a square plus b square upon E. E square is equals to a square plus b square upon a square. E dash be the eccentricity of the conjugate hyperbola, that is y square upon b square minus x square upon a square is equals to 1. E dash is equals to in root of a square plus b square upon b. Therefore, E dash square is equals to a square plus b square upon b square. 1 upon E square plus 1 upon E dash square, that is equals to 1 upon E square plus 1 upon E dash square, and that is equals to, these are the values, a square upon a square plus b square plus b square upon a square plus b square, and that is a square plus b square upon a square plus b square, that is equals to 1. Therefore, 1 upon E square plus 1 upon E dash square, that is equals to 1. Fifth one, find the equation of the hyperbola referred to its principal axis, whose distance between the foci is 10 and eccentricity is 5 upon 2. Let the equation of the hyperbola referred to its principal axis be x square upon a square minus y square upon b square is equals to 1. Distance between foci is 2AE, that is equals to 10. Therefore, 2A into 5 upon 2, that is equals to 10, and therefore 5A is equals to 10, A is equals to 2. Now the next is B square is equals to A square in bracket E square minus 1, that is equals to 4 into in bracket 25 upon 4 minus 1. If we simplify, then you will get 4 into 21 upon 4. Therefore, B square is equals to 21. By the equation of hyperbola, that is x square upon, therefore by 1 the equation of the hyperbola is x square upon 4 minus y square upon 21. Second, find the equation of the hyperbola whose distance between the foci is 10 and the length of the conjugate axis is 6. Let the equation of the hyperbola refer to its principal axis be x square upon a square minus y square upon b square, that is equals to 1. Distance between the foci, that is a 2AE, is equals to 10. The length of conjugate axis, that is 2B, is equals to 6, and therefore 2A is equals to 10, A is equals to 5, B is equals to 3, B square is equals to A square in bracket E square minus 1, A square E square minus A square, and that is equals to 3 square minus 5 square minus A square. A square is equals to 25 minus 9, that is equals to 16. A square is equals to 16. Therefore, by the equation of that is by 1 the equation of the required hyperbola, we have now the values of A and B. A square is equals to 16. Therefore, x square upon 16 minus y square upon 9 is equals to 1. Third, find the equation of the hyperbola whose distance between directrix is 8 upon 3 and eccentricity is 3 upon 2. That is the value of the E, and distance between the directrix, that is the 2A upon E. Let the equation of the hyperbola refer to its principal axis be x square upon a square minus y square upon b square is equals to 1. That's the first one. Next is the given conditions. Now the distance between directrix is 2A upon E, that is equals to 8 upon 3. Therefore, A is equals to 4A upon 3. That is a 4 upon 3 into 3 by 2. That is 3 get cancelled. A is equals to 2. Next is B square is equals to A square in bracket E square minus 1. That is a 4 into the value of E square, which is 9 upon 4 minus 1. And after simplification, that is a 4 into 5 by 4, that is equals to 5. B square is equals to 5. A square is equals to 4. Therefore, by 1, the equation of the required hyperbola is x square upon 4 minus y square upon 5 is equals to 1. Next is fourth one, whose the length of conjugate axis is equals to 12. and passing through 1 minus 2. Let the equation of the hyperbola referred to its principal axis is x square upon a square minus y square upon b square is equals to 1. Therefore, the length of conjugate axis, that is the 2b, is equals to 12. Therefore, b is equals to 6. And hyperbola passes through the point 1 minus 2. Therefore, it satisfies the equation that is x square upon a square, that is the 1 square, minus 2 square upon b square, that is equals to 1. That is the value of the b, that is we are substituting, that is a 6 square. Therefore, we will get the value of 1 upon a square is equals to 1 plus 4 upon 3. And that is equals to 9, 10 upon 9, 1 upon b square, a square is equals to 10 upon 9. And therefore, a square is equals to 9 upon 10. Therefore, by 1, the equation of the required hyperbola is x square upon a square minus y square upon x square upon 9 upon 10 minus y square upon 36, that is equals to 1. That is the 10x square upon 9 minus y square upon 36, that is equals to 1. Fifth one, which passes through the points 6, 9 and 3, 0. Let the equation of the hyperbola is x square upon a square minus y square upon b square, that is equals to 1. It passes through the point 6, 9 and 3, 0. Therefore, it satisfies that equation. 9 upon a square minus 0 upon b square is equals to 1. 36 upon a square minus 81 upon b square, that is equals to 1. That is equals to a square is equals to 9, and 36 upon 9 minus 81 upon 1 b square, that is equals to, if you simplify it, then you will get 4 minus 1, that is equals to 81 upon b square. Therefore, b square is equals to 81 upon 3, that is equals to 27. A square is 9. Therefore, the required hyperbola x square upon 9 minus y square upon 27, that is equals to 1. Sixth one, whose vertices are plus or minus 7, 0 and endpoints of the conjugate axis are plus or minus 3, 0 plus or minus 3. Now here, let the equation of the hyperbola refer to its principal axis be x square upon a square minus y square upon b square is equals to 1. Then vertices are plus or minus a comma 0, which are given to be plus or minus 7, 0. Therefore, a is equals to 7. Endpoints of the conjugate axis are 0 plus or minus b, which are given to be 0 plus or minus 3. B is equals to 3 by 1. The equation of required hyperbola is x square upon 49 minus y square upon 9, that is equals to 1. Next is whose foci are at plus or minus 2, 0 and eccentricity is 3 by 2. Therefore, let the equation of the hyperbola referred to its principal axis be x square upon a square minus y square upon b square is equals to 1. The coordinates of foci are plus or minus a, 0, which are given to be plus or minus 2, 0, a is equals to 2 and e is equals to 3 by 2. Therefore, a into 3 by 2, that is equals to 2. Therefore, the value of a is 4 upon 3. B square is equals to a square in bracket e square minus 1. After substituting, we will get, that is a square e square minus a square. 2 square minus 4 upon 3 bracket square. Simplification. 4 minus 16 upon 9. 20 upon 9. Therefore, the equation of a required hyperbola is x square upon 16 upon 9 minus y square upon 20 upon 9, that is equals to 1. 9y square upon 16 minus 9x square upon 16 minus 9y square upon 20, that is equals to 1. Eighth one. Find the equation of the hyperbola whose length of the transverse and the conjugate axis are 6 and 9 respectively. Let the equation of the hyperbola referred to its principal axis be x square upon a square minus y square upon b square is equals to 1. Next is a length of transverse axis is 2a is equals to 6. Therefore, a is equals to 3. Length of conjugate axis, that is 2b is equals to 9. B is equals to 9 upon 2. Therefore, by the equation of the required hyperbola is x square upon 9 minus y square upon 81 upon 4, and that's equals to 1. X square upon 9 minus 4y square upon 81, that is equals to 1. Ninth one, whose length of transverse axis is 8 and distance between foci is 10. Let the equation of the hyperbola referred to its principal axis be x square upon a square minus y square upon b square is equals to 1. Length of transverse axis, that is equals to 2a. Distance between the foci, that is equals to 2ae. 2a is equals to 8, a is equals to 4, 2a is equals to 10, therefore a is equals to 5. B square is equals to a square in bracket a square minus 1. A square is square minus a square, that is a 5 square minus 4, that is equals to 25 minus 16 is equals to 9. B square is equals to 9. Therefore, the equation of the required hyperbola is x square upon 16 minus y square upon 9, that is equals to 1. Find the equation of the tangent to the hyperbola. First, 3x square minus y square is equals to 4 at the point 2 root 2. The equation of the hyperbola is, that is a 3x square minus y square is equals to 4, dividing on both sides by 4, that is a x square upon 4 upon 3. If we divide by 4, that is a 3 by 4, which is nothing but x square upon 4 upon 3 minus y square upon 4, that is equals to 1. Comparing with x square minus a square minus y square upon b square is equals to 1, we get a square is equals to 4 upon 3, b square is equals to 4. The equation of the tangent to the given hyperbola at the point 2 root 2 is, that is x1 upon a square minus y1 upon b square is equals to 1. Now simplify it. That is a 2x into 4 upon 3 upon 4 minus, that is a root 2 upon 2 into y, that is equals to 1. That is a 3x upon 2 minus root 2y upon 2 is equals to 1. 3x minus root 2y is equals to 2 after simplification. Second, 3x square minus 4y square is equals to 12 at the point 4, 3. Now the equation of the hyperbola is 3x square minus 4y square, that is equals to 12, dividing on both sides by 12. That is a 3x square upon 12 minus 4y square upon 12, that is equals to 1. X square upon 4 minus y square upon 3, that is equals to 1. Comparing with x square upon a square minus y square upon b square is equals to 1, we get a square is equals to 4, b square is equals to 3. The equation of the tangent to the hyperbola x square upon a square minus y square upon b square is equals to 1 at the point P x1 y1 is on it is, that is x1 upon a square minus y1 upon b square, that is equals to 1. Therefore, the equation of the tangent to the given hyperbola at the point 4, 3 is, that is 4x upon 4 minus 3y upon 3, that is equals to 1, which is nothing but x minus y is equals to 1. Now next is third one. X square upon 144 minus y square upon 25 is equals to 1 at the point whose eccentric angle is pi upon 3. The equation of the hyperbola is x square upon 144 minus y square upon 25, that is equals to 1. Comparing with x square upon a square minus y square upon b square is equals to 1. A square is 144, b square is 25, a square is 12, b is 5. Therefore, the equation of the tangent to the hyperbola x square upon a square minus y square upon b square is equals to 1 is at the point p theta x into sec theta upon a minus y tan theta upon b, that is equals to 1. The equation of the tangent to the given hyperbola is at p pi by 3 is x sec of pi by 3 upon 12 minus y tan of pi by 3 upon 5, that is equals to 1. Therefore, x into 2 upon 12 minus y into root 3 upon 5, that is equals to 1. Therefore, x upon 6 minus root 3y upon 5, that is equals to 1. 5x minus root 3y into 6, that is equals to 5 into 3 is equals to 30. This is 30. Therefore, this, that is the 5x minus 6 root 3y is equals to 30. This is the required equation of the tangent. Now next is fourth one. X square upon 16 minus y square upon 9 is equals to 1 at the point in the first quadrant whose ordinate is 3. Ordinate means what? X coordinate and abscissa. Ordinate abscissa and the ordinate. Ordinate means y coordinate. That is comparing with x square upon a square minus y square upon b square is equals to 1. We get a square is 16, b square is equals to 9. The point P, K3. Now we have the abscissa and the ordinate. Abscissa means x coordinate and the ordinate means y coordinate. Therefore, we have given the y coordinate and substitute these values. The point is in the first quadrant. Ordinate is 3. P lies on the hyperbola. It satisfies the equation of the hyperbola. That is k square upon 16 minus 1 is equals to 1. Therefore, k square is equals to 32. Therefore, k is equals to root of 32. Because that point lies in first quadrant, we are taking its a plus. That is, k is equals to 4 root 2. The equation of tangent to the hyperbola x square upon a square minus y square upon b square is equals to 1 at the point x1 y1 is x1 upon a square minus y1 upon b square is equals to 1. The equation of the tangent to the hyperbola at point 4 root 2 comma 3 is, that is, x1 upon a square minus y1 upon b square is equals to 1. That is, 4x into 4 root 2 upon 16 minus y into 3 upon 9, that is equals to 1. That is x root 2 upon 4 minus y upon 3, that is equals to 1. If we take the cross multiplication, x into 3 root 2 minus 4y, that is equals to 12. That is 3 root 2 x minus 4y is equals to 1. That is equals to 12, sorry. I will repeat it again. Let me simplify it. That is equals to 12. That is 3 root 2x minus 4y is equals to 12. Next is fifth one, 9x square minus 16y square is equals to 144 at the point capital L of the lattice rectum in the first quadrant. The equation of the hyperbola 9x square minus 16y square is equals to 144. X square upon 16 minus y square upon 9, that is equals to 1. A square is equals to 16, b square is equals to 9. We get a square is 16, b square is 9, a is 4, b is 3. Eccentricity e is equals to in root of a square plus b square upon a, that is 16 plus 9 upon 4, that is a 25 upon 4, 5 by 4, e is 5 by 4. A is equals to 4 into 5 by 4, that is 4 get cancelled, you will get the 5. The end of the lattice rectum, that is the end points in the first quadrant, is a comma b square upon a, 5 comma 9 by 4. Therefore, the equation of the tangent to the hyperbola x square upon a square minus y square upon b square is equals to 1 at the point x1 y1 is x1 upon a square minus y1 upon b square is equals to 1. Now substitute the values. Therefore, the equation of the tangent to the given hyperbola at L is x into 5 upon 16 minus y into 9 by 4 upon 9, that is equals to 1. 5x upon 16 minus y upon 4, that is equals to 1. Then 5x minus 4y, that is equals to 64. This I will repeat here. 5x minus 4y is equals to 16. Sorry, it is not the 64, it is 16. Now the next is number 7. Show that the line 3x minus 4y plus 10 is equals to 0 is tangent to the hyperbola x square minus 4y square, that is equals to 20. Also, find the point of contact. We know that y is equals to mx plus c is a tangent to the hyperbola, that is x square upon a square minus y square upon b square is equals to 1. If c square is equals to a square m square minus b square, and the point of contact, that is a minus a square m upon c minus b square upon c, given hyperbola x square minus 4y square is equals to 20, that is x square upon 20 minus y square upon 5, that is equals to 1. Therefore, a square is 20 and b square is 5. Given line is 3x minus 4y plus 10 is equals to 0. Therefore, we write it in the form y is equals to mx plus c. That is 4y is equals to 3x plus 10. Divide on both sides by 4. Then you will get y is equals to 3 by 4x plus 10 upon 4. That is y is equals to 3 by 4x plus 5 by 2. That is equals to m is equals to 3 by 4 and c is equals to 5 by 2. C square is equals to a square, that is a c square is equals to 5 by 2, which 5 by 2 bracket square, that is a 25 by 4, and a square m square minus b square is equals to 20 into 3 by 4 bracket square minus, that's a value 5. If you simplify it, then you will get, that is a 25 by 4, and that's why a square m square minus b square, that is equals to 25 by 4, which is equals to c square. Therefore, the given line is a tangent to the hyperbola. Let P x1 y1 be the point of contact. x1 is equals to minus a square m upon c minus 20 into 3 by 4, that is the value of the c is 5 by 2, and if you simplify it, x1 is minus 6, and the same thing is a y1 is minus b square upon c. Substitute the values, that is y1 is minus 2 minus 5 upon minus 5 by 2 minus 5 upon 5 by 2, that is equals to minus 2, y1 is minus 2. The point of contact is minus 6 minus 2. Next is problem number 8. If 3x minus 4y is equals to k touches the hyperbola x square upon 5 minus 4y square upon 5 is equals to 1, then find the value of k. We know that y is equals to mx plus c will be the tangent to the hyperbola x square upon x square minus y square upon b square is equals to 1. If c square is equals to a square m square minus b square, given hyperbola x square upon 5 minus 4y square upon 5 that is equals to 1. X square upon 5 minus y square upon 5 by 4 that is equals to 1. A square is 5, b square is 5 by 4. Given tangent is 3x minus 4y is equals to k. Therefore, we will express in the form of the y is equals to mx plus c. That is the 4y is equals to 3x minus k. Therefore, y is equals to 3 by 4 x minus k upon 4. The value of m is 3 by 4. C is a minus k upon 4. Applying the tangency condition, c square is equals to a square m square minus b square. We get the value of c minus k by 4 bracket square 5 into 3 by 4 bracket square minus that is a 5 by 4, and after the simplification that is a k square upon 16 is equals to 5 into 9 by 16 minus 5 by 4 that is 45 upon 16 minus 5 by 4. Their simplification 45 minus 20 upon 16 that is a 25 upon 16, k square is 25, and that's why k is equals to plus or minus 5. Ninth, find the equation of the tangent to the hyperbola x square upon 25 minus y square upon 9 is equals to 1. Making equal intercepts on the coordinate axis. Equation of the hyperbola x square upon 25 minus y square upon 9 is equals to 1. Comparing with x square upon a square minus y square upon b square is equals to 1, we get a square is 25, b square is 9. The equation of the tangents to the hyperbola x square upon a square minus y square upon b square is equals to 1 with slope mr, y is equals to mx plus or minus in root of a square m square minus b square. The tangent makes equal intercepts on the coordinate axis. The slope is m is equals to minus 1. That is, the tangent is making the equal intercept. It makes an angle of that is a 135, and the tan of 135 that is equals to minus 1. The equation of the required tangent are y is equals to minus x plus or minus 4, that is x plus y is equals to plus or minus 4. The problem number 10. Find the equation of the tangents to the hyperbola 5x square minus 4y square is equals to 20, which are parallel to the line 3x plus 2y plus 12 is equals to 0. Find the equation of the tangent to the hyperbola which are parallel to this line. Therefore, that is the slope of the tangent and the given line are equal. Therefore, we have the value of the m. Now, the equation of the tangent to the hyperbola x square upon a square minus y square upon b square is equals to 1 in terms of slope mr, y is equals to mx plus or minus in root of a square m square minus b square. Given hyperbola is 5x square minus 4y square is equals to 20. That is x square upon 4 minus y square upon 5 is equals to 1. Therefore, comparing, we will have the value of a square is 4, b square is 5. Therefore, slope of 3x plus 2y plus 12 is equals to 0. That is, 2y is equals to minus 3x minus 12. Therefore, y is equals to minus 3 by 2x minus 6. Therefore, m is equals to minus 3 by 2. The required tangent is parallel to, required line is parallel to the tangent. Therefore, its slope is m is equals to minus 3 by 2. And that's why by 1 the equation of the required tangents are y is equals to minus 3 by 2x plus or minus in root of 4 into 9 by 4 minus 5 by 2, that is after simplification, that is equals to y is equals to 2y is equals to minus 3x plus or minus 4, that is a 3x plus 2y plus or minus. I will now see this. 3x plus 2y is equals to plus or minus 4, and in this way we have completed the conic section, that is a parabola, hyperbola and the ellipse. I hope that you will understood all the problems whatever that I had explained. Now we'll see in the next video. Till then, goodbye.